Hello everyone, welcome to Lab 9, Part 2. In this lab, we will take what we learned in Part 1 and apply it to the steps to configure an application module. The application module we will use is going to create a positioning program in the MOVIDRIVE, so we don't have to write the program from scratch. There will also be a graphical interface we will use to monitor the state of the program when we are controlling the MOVIDRIVE from the digital inputs. At the end of this lab, you should have a better understanding of what application modules are, how to configure and download them, and the process of operating a positioning application with the MOVIDRIVE. We talked about this in the Session 2 video, but I will mention it again that there are two application levels of the MOVIDRIVE, either being standard or technology. The application modules that are selectable in Motion Studio can only be downloaded to a MOVIDRIVE with the technology application level. If the MOVIDRIVE has a standard application level, then the application modules are not allowed to be downloaded to it, but the standard version will still support custom IPOS programs. If you have access to the stickers on the MOVIDRIVE, you can see which application level it was ordered with. You will look at the last two characters and see if it shows 00 or 0T. If you can't see the stickers on the MOVIDRIVE, you can check parameter 079 and read the application level there. It will either say standard or technology. Don't get confused by the technology function parameter that's above. This parameter uses similar naming, but is for specific IPOS functions, and it does not represent the application level of the MOVIDRIVE. If you find that you're working with a MOVIDRIVE that has the standard application level, and you need to use one of the application modules, it's possible to upgrade the application level using Motion Studio. You will need to contact your local SEW office to purchase the technology level for the MOVIDRIVE you have, and they can talk you through upgrading the level using the Motion Studio software. The application module that we will be demonstrating today is called Table Positioning. Now, this application module does not mean it's only for applications that have a table that positions. It means there are a table of values that are configured in the application module, and when it's operated by the digital inputs, we can use a binary combination that chooses from different rows of the table. This gives us the ability to travel to different positions with different ramp times and speeds without the need for an upper-level PLC to set all of those set points. We will also have the ability to teach new positions as well for scenarios when reconfiguring the application module parameters isn't practical just to update the position. All right, let's head into the software and get started with demonstrating this application module. Here we are back in the software, and you may notice that I am now communicating to the MOVIDRIVE over a serial cable instead of an Ethernet cable. The reason I'm doing that is because some application modules will require you to be connected over a serial cable if you want to control the MOVIDRIVE directly from the graphical interface of the application module. Not every application module requires that, but to make sure that I don't have any kind of issues, I've just decided to use a serial cable instead. In Lab 8, we set up the MOVIDRIVE in a CFC operating mode, which gives us better dynamics, and then we tuned it so our MOVIDRIVE is now prepared to handle a positioning application. But I don't want to modify the parameter backup that we have in our project from the previous lab. So I need to change the name of my MOVIDRIVE to the new lab that we're conducting right now. But one thing I want to point out to you is that currently the online MOVIDRIVE is linked to the offline project file that we have. If I click to a different lab backup, and then click back to the MOVIDRIVE that's online, you'll see that it jumps to the same MOVIDRIVE in the offline project because it is currently linked. If I change this name here, it's going to change the name of my backup from the previous lab, and I don't want to do that. So let's go ahead and duplicate this backup so that way I can change this name for our new lab. So I'm going to right-click on the MOVIDRIVE B, then click on Create Copy. It's going to propose a name for me that's different than what it's currently set to, and I'm okay with that name, and I'm going to click on OK. And there we go. We have a copy from Lab 8. So now I can change the name of our online MOVIDRIVE to our current lab. So let's name this MDXB table app for the table application, and then click on OK. And we can see that it now changed the name of this offline project backup. Now, technically speaking, these are the same file. They just have different names, but we will overwrite this backup once we load the table application and then we test it. If I want to put this back to what the name was before, then we can just right click on it, go to properties, and then delete this _2, and then click on OK. It's going to tell me that there's a folder that already exists with that. Do I want to overwrite it? I'm fine with that. So I'm going to say yes. And then there we go. We have it backed up the way we want. So we have our previous Lab 8 parameters, and then we also have the ability to store parameters for Lab 9 Part 2. All right, the next thing I want to show you is in the parameter tree of our online MOVIDRIVE. So let's right-click on our MOVIDRIVE, go to the parameter tree, and then let's go to this option here that's called IPOS information and double-click it. And then here we go. We can see that task 1, 2, and 3 for the IPOS program are currently stopped because we do not have a program in it, so there's nothing to run. And then we can see in this empty box down here, if we had some type of IPOS program in here, it would give us some information about that program, but we don't have anything in there, so it's currently blank. Now, what the application module is going to do is the application module is just a graphical interface for an IPOS program that's already been developed and tested. And it's also well documented. So if you're wanting to do positioning with the MOVIDRIVE, an application module is a much easier route to take than trying to develop your own IPOS program from scratch. Another situation I want to point out is when you are trying to determine how many encoder increments happen between two different points when you are trying to determine your position scaling. Well, you can come into this IPOS information tab and then look at these H variable numbers here, 511, 509, or 510, depending on how you are getting your encoder signal into the MOVIDRIVE. And then you can calculate what the beginning increment count is, and then what the ending increment count is, and then determine the difference between those 2 points. It's very important that you do that calculation before you load an IPOS program or an application module to the MOVIDRIVE, because it is possible for these numbers to be influenced by some math in an IPOS program. So you don't want to try to determine your scaling after loading an IPOS program to the MOVIDRIVE, because it may not be accurate if these positions have been manipulated in some way. All right, we can go ahead and close this parameter window. And then let's open up the display values parameters and then process values. So that way we can see the speeds and the position that the motor will run at, and we can collapse this. And then now let's open up our application modules. So I will right click on our online MOVIDRIVE, go to application modules, and here we see a list of different applications to choose from. It's very possible, depending on what type of application you have, that we have an application module that could work for that application. So definitely look through our documentation and see if we have something that could work for you. But if you did need to load a custom IPOS program, either from a manufacturer or something you created yourself, then that's going to be in a different area called programming, and then IPOS assembler or compiler, depending on which tool they used to create the program. Custom IPOS programming is not a topic that we're going to cover in this training series, so I just wanted to point out that if you do have an IPOS file that you're trying to get into your MOVIDRIVE, that you would need to come to either one of these options, depending on which file you have, to download that into the MOVIDRIVE. So let's head back to our application modules. And then in this lab, we're going to be doing table positioning. If you look down here to the bottom of the list, you'll see that there are two versions of table positioning. The difference between these are either doing table positioning with the digital inputs or doing it over a field bus control word. We're not going to be using a control word and a field bus, so we're just going to be using our digital input switch box. So we're going to choose this first option here. I do want to preface that if you go the digital input route, you will need an expansion card on the MOVIDRIVE that adds more inputs and outputs, because this application module will require more inputs than are on the standard MOVIDRIVE. So let's go ahead and open up this application module, and it will take a second to open. And this first pop-up is just telling us that there is a help file attached to this application module, so I can show you that by clicking on the help button. And depending on what kind of information you need, there are different categories that you can navigate through here for this application module, and it will give you a lot of information about how to commission it and how to operate it. So this is just a quick way to get some information about this if you have some questions. We also have dedicated manuals that you can download off of our website that are for each application module that we offer. So if you're working with an application module and need more information or either in-depth information, go to our website to download the manual that is specific to the application module you are using. All right, we can go ahead and close this. And then it went ahead and closed that pop-up for us as well. If you ever need to get back to the help, then there is this yellow question mark right here that you can click that will reopen that help file for you. The first thing the application module is wanting to know is our position scaling. So if you have already calculated the scaling manually, then you can enter in that numerator and denominator here directly. But if you have not calculated it manually and you want the application module to calculate it, then you can use this top box here and then enter in the values of your application. There's also some more specifics. If you don't have a diameter of a driving wheel, there's another option here for a spindle slope. So if you have an application that uses a spindle instead of a driving wheel, then you can calculate that one as well. But for this demo, we are using just a flywheel on the end of the motor shaft. So I'm going to say diameter of driving wheel. The diameter of our flywheel is 120 millimeters, so I will type in 120. And there is no gearbox or external ratio for our demo motor, so we're just going to leave that 1:1. Now, if I press this calculate button, it's going to go ahead and use this diameter and then the unit millimeters to automatically calculate how many encoder increments will happen per millimeter. So if I press the calculate button, we can see we have a numerator and a denominator now that equates to how many encoder increments we should have per millimeter. Now, if you don't want to use the unit millimeter, then you can just type in a new unit here. So say, for instance, if you wanted to use inch, then you can just type in inch, and it will change the unit throughout the rest of the application module. But if you do use a custom unit that is different than millimeters, it'll be your responsibility to make sure that this numerator and denominator position scaling is accurate for whatever unit you have entered. I'm okay using millimeters, so we're just going to change this back to millimeters. The next piece of information the application module wants us to enter is if we want to use any software limit switches. Now, if we don't want to use these, then we can just leave these values to 0 and it deactivates that function. But if we do want to enter these, then we need to enter in the value for our unit at where we want our software limit switches to be. So this is an additional measure that we can use to protect the machine from going outside of travel limits that can possibly cause issues with the machine. So we will be using that in this lab to demonstrate that. So let's load in some software limit switch distances. And we'll set our clockwise distance to 21,000 millimeters. And then we'll set our counterclockwise distance to negative 21,000 millimeters. And we can see now that there are some red markers here at the bottom indicating in our travel distance range where the software limit switches will be. The next thing we have a question about is the hardware limit switch. You can leave this to yes, which is the default setting, or no, and we will be using the hardware limit switches, so we will say yes. The software limit switches are supposed to be placed inside of the distance of the hardware limit switch. So just know that when you enter in the software limit switch value, check to make sure it is actually before you would hit a hardware limit switch. The next thing the application module is asking us for is the reference offset. And I didn't talk about this in part 1 of this lab, but the reference offset is a value that we can set for when the reference routine is complete. Do we want it to read different than 0? By default, when we reference the equipment, it's going to set the encoder at a 0 distance. But if we want it to read, say for instance, 1200 millimeters, then we can type in 1200. And then once we reference the equipment, instead of it reading 0 at that position, it will now read 1200. I do want to preface that the machine will not physically move 1200 millimeters after it's referenced. It's only a change to the readout of the position of where it's referenced. It doesn't physically move this distance. It's just a digital change of the position. But we're not going to be using the reference offset, so we're just going to set this back to 0, and then wherever we reference the equipment, the position will be 0 in that location. The next thing we have to set is our source of our actual position. Now today we're going to be using our motor encoder for our position, but there are applications that have external encoders or absolute encoders that they rather get the position from those. So if you have an application that uses external encoders, then you can change the source to be looking at those external encoders for the position instead of the motor encoder. And these values in parentheses are just the port numbers of the MOVIDRIVE. So the motor encoder always plugs into port X15. The port above the motor encoder input is called X14, and that's where an external encoder could plug into. And if you were using an absolute encoder with this application module, then you would be using a DIP absolute encoder card, and that's where you would plug that encoder in at. The next thing we have to set is the reference travel type, and we talked about this in part 1 of our lab. And if we click our drop-down menu, we'll see the different numbers of the different reference routines that we can set. And if we choose one, we can see that the graphic will change. So you will need to understand what these different numbers mean, because it is changing the type of reference travel that will happen when the routine is called up. But for this application, since we don't have a physical piece of equipment, we're just going to choose type 8, which will allow us to set the reference wherever the motor is currently located. And with type 8, we don't have to have the enable on the MOVIDRIVE, so we can even do that if the MOVIDRIVE was only powered to 24 volts as well. All right, let's go ahead and click the next button. This top screen is asking us for the parameters we want to use if we were in a jog mode. So I will set the rapid speed for jog mode to 1500 RPM, and then a slow speed that is not so slow that we overheat our motor. So I'm going to choose 500 RPM, and then let's do a ramp of 2 seconds. And then now we need to build our position, ramp, and speed table. So that way when we alternate the digital inputs, we can call up different positions and then travel to those using different ramps and different speeds. So on the screen here, we have a list of positions. And so let's build this table for our application module. For row 0, we want to travel to 20,000 millimeters, so I will type in 20,000. And then we want to travel at half a second ramp when we're doing that routine. And then we want to be at 500 RPM. Now I'll click this Add button to give me another row of our table. And the next position should be negative 20,000 millimeters. So I'll type in negative and then 20,000. And we want to travel to that using a 1 second ramp at 1500 RPM. And I'll click the Add button to give another row for the table. And then I'm going to speed through this and just keep building this table out. Okay, so we have built the table, and then when I press enter for row number 4, we will see that now we have completed our different positions, and we now have blue tick marks along our travel range that tells us where each position will be located inside of our software limit switches. Now this view down here does not show the hardware limit switch because this application module doesn't store the location of the hardware limit switches. So it's only showing the software limit switches, since those are located at absolute positions. Now all we have to do is press the next button. It's going to ask, do I want to save the changes? Now you don't have to save this file to get it into the MOVIDRIVE, but it could be helpful if you ever want to look at these settings when you're not connected to the MOVIDRIVE, or if you have multiple MOVIDRIVEs that will use this program. It could be helpful to go ahead and just have a backup of these commissioning parameters, so that way each MOVIDRIVE gets the same settings if that's your intention for the application. So I'm just going to click on yes. It's going to default to our device name inside of our Motion Studio project folder. So then I can just call this table app, and then I'll give it V1 for version 1, and then click on save. Then it jumps me to the next screen, but let me show you where we save that at. So let's pull this out of the way and then come into our project folder and then go to devices. Then we can see that this is our new device name that we changed. So MDXB table app, and click into it. And then there is the file that we just saved, table app v1.tab, which is for the table application module. So if you need to load that to other MOVIDRIVEs, then check your devices folder and then your device name to see if that's where that file was saved. You can, of course, save this file to different locations as well if you don't want it inside of the devices folder of your Motion Studio project. So we can just close out of this and then come back into Motion Studio and then reopen our application module. And now the last thing of our application module is just to download it into the MOVIDRIVE. So when we saved that file, it did not actually move anything to the MOVIDRIVE. It just gave us a commissioning parameter file on our computer that we can look at later or duplicate to the other MOVIDRIVEs. To actually get this IPOS program into the MOVIDRIVE, we have to press this download button. So now I will press the download button. And it tells me the download was successful. Do I want to change to the monitor window? And I'm going to say yes, I want to change to the monitor window. And now we're in the monitoring window of table positioning. But let me show you that IPOS information parameter again. So let's go back to our parameter tree and then double click on IPOS information. And then we can see that task 1, 2, and 3 are now all running. And it also loads some information about the IPOS program here down below. And we can see that the origin of the program came from table positioning. Okay, we can go ahead and close out of this, and let's reopen our application module screen. Now we're back in the monitoring view of table positioning. And you may see that it's a little bit cut off right here, so all I have to do is open this up a little bit further. And then this is a key for the different mode settings that we can use for either jog mode, teach mode, reference travel, or automatic. So this is just a key here. If you don't need to see the key, then you can just close this window and it will be out of the way. So just pay attention to the application module screen. There could be some information that may be cut off if the window is not big enough. Now looking at the top piece of our monitor window, it gives us the status of our binary inputs of the standard MOVIDRIVE. And it gives us the status of the binary inputs of the expansion card that we have installed. Here is the current mode status of the application module, an actual position of our encoder, and here are some digital outputs that the application module is using. And then below is our different table of positions that we loaded. And if you happen to notice any of the positions or the ramp time or the speed is not correct, or if you want to modify that, then you can just click on the commissioning button here at the bottom, and it will reopen the commissioning of the application module, and then you can make any changes you need to, and then re-download those to the MOVIDRIVE. Just know if you do decide to make a change, so I'll type in 650 and then click next, that it's going to ask you if you want to save those changes, and you can do that if you are saving a backup of your table positioning application. I don't want to make a change to this, so I'm going to click cancel and then put this back to 600. And then click next, and it still knows that I typed something different, so I'm just going to say no, I don't care to save the changes because they're the same. And then now I can just re-download that to the MOVIDRIVE, and it will be the same as what it was before. And then yes, I want to reopen the monitor window. Okay, to demonstrate this application module, we'll need to use our switch box. And I do want to mention that the application module has already assigned functions to our digital inputs, and those assignments are fixed. We can't change those in the parameter tree, so we'll need to be prepared to use the digital inputs that are assigned to these functions. So let's clear our controller inhibit, and then let's give it the enable signal. And it looks like we just caused a fault on the MOVIDRIVE because we can now see that our digital output number 1 that's assigned to /fault has currently went off. So let's check and see what the fault is. So let's pull this out of the way and then go down to the corner here and click on online unit status, and then right click and say display all units. And then here we go. We have fault F27 limit switches, and it says it is missing the limit switch or it's a broken wire. So let's pin this here so we can see that, and then go back to our application module. And what we did wrong was we did not activate our limit switch terminals before we gave it the enable signal. So the equipment thought that we were either on the limit switch or that the switches aren't connected, so it caused a fault. So just remember, just like our controller inhibit that has the slash before it, the limit switches also have this slash symbol before it, meaning that they are active low inputs. So we have to have the input on to not cause a fault. If the input goes off, then it will cause a limit switch fault. So let's deactivate our enable and our controller inhibit and activate digital input 4 and digital input 5 for our limit switches. And then now we can see that our digital input assignment to reset a fault is programmed to digital input number 2. So let's toggle digital input number 2 on and then off. And we can see now that the fault is resetting on the MOVIDRIVE. And we have our output back on for digital output number 1 saying that there is not currently a fault. Okay, the current status of the application module is in jog mode, and we can confirm that by looking at our digital inputs and see that digital input 10 and 11 are currently off, and our key shows us if both those inputs are off, then we would be in jog mode. So let's run the MOVIDRIVE in jog mode. So we will need to clear our inhibit and then give it the enable signal. And then we're still missing one piece to be able to jog the motor, and that is digital input 13 or 14. So jog plus would be clockwise direction, and jog minus would be the counterclockwise direction. So let's go ahead and activate jog plus. All right, and we can see the motor is now turning in the clockwise direction, and it is rotating at 500 RPM. And we can see that over here in the corner that the speed is 500 RPM. Now let's go ahead and stop that jog mode. And then let's activate the other direction. All right, and then now it's going counterclockwise, but we're still running at 500 RPM, and we have a rapid speed that we set to be at 1500 RPM. Well, if we want to be able to jog and be in the rapid speed mode, then we need to activate our digital input 15 for the rapid speed. So let's turn on digital input 15. And now we are running at 1500 RPM. So let's activate the other direction by turning off jog minus, and then the motor will stop, and then let's turn on jog plus, and then now we're running in the clockwise direction at 1500 RPM. Now we can go ahead and stop this by just turning off the jog signal, and then we'll deactivate this rapid speed. And then if we look at our actual position, it's a really high number because our demo motor uses an absolute encoder. And if you look down here to the bottom of our application module screen, you can see this green arrow is pointing off screen, meaning that our position is way outside of our software limit switches. So once we do our reference routine, it should correct that because we can see that digital output 02, the IPOS reference, is currently off, meaning that we haven't referenced it. So let's go ahead and reference this equipment. And if we look at our key, we can see to do a reference travel, it will be digital input 11 is on and digital input 10 is off. So let's go ahead and turn off our enable so that way it doesn't do anything just yet, and then activate digital input 11. And we can see that now our status of our application module shows reference travel. And then it also changed our assignment of our binary inputs. So the assignment on the left of the binary inputs of the basic unit didn't change, but the assignments of our expansion card did change now with this new mode. So now we have to look at our options to be able to reference. And it looks like we only have digital input 12 start reference travel, and then a software limit switch disable if we needed to do that. And since we are in a type 8 mode, we don't need to enable our MOVIDRIVE to be able to set the reference. So let's just toggle digital input 12 to set the reference. So we'll go on, then we'll wait a second and then go off. And now looking at our application module screen, we can see that the digital output number 2 for the IPOS reference has switched on, and our actual position now shows 0 millimeters. And if you look to the bottom where the positions are, the green arrow is no longer pointing off screen and is now in the center pointing at the 0 millimeter marker. Now that we have referenced our equipment, we should be able to go into automatic mode and then travel to each one of the positions that we have programmed in our table. And to go to automatic mode, it says we need to activate digital input 11 and digital input 10. Let's activate digital input 10, and our enable signal is currently off, so we know we're not going to move. So let's activate number 10, The status now shows reference travel not referenced, but this isn't an actual error because the status of these binary inputs of the expansion card are still set to the reference travel mode. So the only reason it's showing this message is because the mode hasn't changed yet. This should change after we switch on the enable input, so let's switch that on. And there we go, the brake is now released on the motor, and then our status of our application module now shows automatic. We can see that our binary inputs has changed again, and we have value 1, 2, 4, 8, and 16 for the different inputs. And these inputs will create the binary coding we need to switch between the different rows of our positioning table. Row 0, 1, 2, 3, or 4. So you will need to understand how to change the combination of these inputs to equal different decimal numbers. But without activating any of these inputs, we can see that currently row 0 is called up as the position. So if we give it the start position command, then we should travel to 20,000 millimeters at half a second ramp and a speed of 500 RPM. So let's test that by toggling digital input 12. All right, and we can see the motor is now traveling, and our arrow at the bottom is now moving. It stopped at the 0 tick mark, and it tells us that digital output number 17, the position is reached. Okay, let's try a different position. So let's go to row 1, and to do that, we need to activate digital input 13. We'll need to turn off the start command on input 12 so that it doesn't move automatically, and then activate 13. And we can see now that our row 1 is active. So let's go ahead and send the start position again for that, and let's travel to negative 20,000 millimeters. And it's going much faster now because it's going at a speed of 1500 RPM. And now we are in position. So let's keep trying the other rows of our table. So to activate row 2, I need to turn off 12 so that way we don't move. And then let's turn off 13 and then activate 14. And now row 2 is called up at 10,000 millimeters. So let's send the position for that by toggling start position. And there we go. Now we are traveling. Our arrow is moving. And it is now stopped on the tick mark 2 for 10,000. Let's try row 3. So this is where we will need to combine two inputs to activate row 3. And the binary coding of these inputs means that I will need to activate 13 and 14 to get row 3 to come up. So let's go ahead and deactivate 12, then activate 13 and 14, and we can see that now row 3 is called up. So let's go ahead and travel to negative 10,000 millimeters. There's the start position. And we're going much faster now as well because of the 1200 RPM. And now we are stopped at position 3, and digital output 17 for the position reached is active. Now let's go to position 4. So to do position 4, we only need to activate digital input 15. We'll need to turn off input 12 and turn off 13 and 14, then activate input 15. And now row 4 is called up. So let's go ahead and travel to 500 millimeters. And there we go. We're now traveling to 500 millimeters, and now it is in position, and we can see our arrow is aligned with number 4 now. Okay, let's present a scenario where we want to change a position without having to go back into the commissioning of the application module. Well, we can do that with the teach mode. And if we look to our key over here on the right, we can see that teach mode is activated with digital input 11 turned off and digital input 10 turned on. First, I'm going to deactivate digital input 12 because if I leave this on and then start changing other inputs, it's going to automatically travel to the other positions because I'm giving a start command already. So I always need to make sure I remove the start command before I change the inputs, otherwise it could activate the other positions. So let's go ahead and turn 12 off, and then now we can turn off 15. And then if we activate teach mode, we just need digital input 10 on. So I'll turn off 11. And we can see now that teach mode is turned on. But if we just teach a new position, it's only going to teach our current position that we're at, which is 499 millimeters. So if I want to travel to a different position and teach that, I need to do that first. So what we actually need to do is go into jog mode. So we need to turn off teach mode. And then now we are in a jog mode. And so let's just jog to a new position. And to do that, I'm just going to choose the counterclockwise or the clockwise direction and then move it to a position that is not currently on our table. So let's just activate the counterclockwise direction, then travel a few rotations and then turn it off. And it says we are at negative 7,920 millimeters. Okay, let's go ahead and teach that for row number 4. So I need to activate teach mode, which is digital input 10 on. And then my input assignment changes. I need to turn on input 15 to activate row 4, which is the one we want to teach the new position to. And the last input I need to toggle to actually load our current position into our table is the strobe input. So that's digital input 12. So let's toggle 12 on and then off. And now we can see that the position is programmed into row 4 of the table. This change is stored into the position variables of the program in the MOVIDRIVE. So we don't have to re-download the commissioning to maintain this position we taught. However, if you are keeping a backup of the application module settings, you would need to reopen the commissioning and save the configuration file like I showed previously so you can keep the backup file you have updated. Now that we have demonstrated the modes of the application module, let's test how the software limit switches function. We can start by jogging our motor to one of our limits, and we are currently closer to the counterclockwise limit, so we can keep traveling in that direction. So we'll deactivate input 15 and then turn off the teach mode. And then let's keep going counterclockwise by just jogging. And then we'll increase our speed so we get there faster. And then it looks like we stopped and we can't jog any further. So let's see what our current position is. It says our actual position is negative 20,986. So that's a little bit before our software limit switch. If you remember from the commissioning, our software limit switches are set to negative 21,000 millimeters and positive 21,000 millimeters. So in jog mode, it lets us get close, but not right on top of the software limit switch. Now, if there's a situation where we needed to travel past the software limit for maintenance or some other reason, we could do that by temporarily activating the software limit switch disable input that's programmed to digital input 17. First, we can turn off the jog minus input so the motor doesn't move. Then we can activate input 17. And then now we should be able to over travel past our software limit switches. So let's try jog minus again and see if we can keep going further. And then we'll deactivate the fast speed as well so it's not going so fast. All right, and then now it lets us travel past the software limit switch. And then if I happen to turn off jog minus mode, and then also turn off the software limit switch disable, and try to continue traveling further from the software limit, we can now see that we caused a fault on the MOVIDRIVE. And if you look down here in the bottom right-hand corner of Motion Studio, it says fault F78 software limit switch approached. So to cause that not to happen, we need to make sure we keep the software limit switch disable turned on if we are in a range that is outside of our software limit switches. To fix that, let's go ahead and just turn off our jog minus mode so we don't move. Let's go ahead and reactivate the software limit switch disable. And then let's fault reset our MOVIDRIVE by toggling digital input number 2. Okay. And then now the fault is reset. And you may notice that we did not lose the encoder reference after resetting the fault. And that's because a software limit switch fault doesn't usually affect the encoder reference. However, there are other faults that can affect the encoder reference, so you may have to redo the reference routine depending on the type of encoder you have connected. Okay, so let's go ahead and just get off of the software limit switches. So I'm just going to jog plus to get back into our normal range. And then let's go faster. And then now we can see our arrow is back into range, so we can stop this and then turn off the fast speed. And we're just a little bit before our positive limit switch. So let's test our hardware limit switches. So let's go ahead and just deactivate this software limit switch disable since we don't need it anymore. And let's go the other direction, back counterclockwise since we're close to our positive limit switch. So we'll activate digital input 14 and start jogging. And if I deactivate one of my limit switches, I'll just choose the counterclockwise limit switch. We can see as soon as I deactivated that, we caused a fault on the MOVIDRIVE, and the fault that is currently shown is F29 hardware limit switch hit. The MOVIDRIVE knows we are on the counterclockwise limit switch, so if we need to back off of the switch, there is a feature in the application module to let us do that easily. What we can do is go ahead and deactivate the direction that caused us to hit the limit switch. But the MOVIDRIVE is still faulted, so we won't be able to move the motor until we clear the fault. What we can do is make sure our MOVIDRIVE has the enable input, so it's allowed to run the motor, then switch on the fault reset input, but instead of it being a quick on and off, we will keep the reset input high. So let's go ahead and activate that. By keeping the input high, you can see that the motor is now slowly backing off of the counterclockwise limit switch by running in the opposite direction. Now we can simulate the limit switch going high again. And once we do that, the motor stops. And we can now switch off the fault reset input, and the limit switch and fault have been cleared. So if you do happen to contact the hardware limit switch, there is a feature of the application module that you can use to back off of the switch without having to go into manual mode to operate the motor. You just have to make sure the MOVIDRIVE is enabled and then keep the fault reset input high, and the MOVIDRIVE will automatically run the motor in the opposite direction of the limit switch until the limit switch signal goes high again. Okay, that is everything I wanted to demonstrate of the table positioning application module, and the only input we did not demonstrate was digital input number 3, the reference cam, and that's because our reference mode is set to type 8, which does not require a reference cam. If you need further information about this application module, we have dedicated manuals that can be downloaded from our website that you can review. Now that we're done demonstrating our application module, we can just go ahead and press the cancel button to close the monitor window. And then we can unpin our online unit status window so it drops out of the way. And then let's back up our parameters to our Motion Studio project. So let's right click on our MOVIDRIVE and then go to Manage Unit Parameter Set. And then I'm going to say Upload. It's going to notify me that I'm going to overwrite the parameters that are currently in the project. And I am fine with that since we want to overwrite those. So that way it's different than our Lab 8 CFC parameter set. So I'm going to say yes. And now it's uploading our online parameters to our offline parameter set. Okay, now the upload is complete. If we go back to our application module, we can right-click on our MOVIDRIVE, then go to Application Modules, and then come down to Table Positioning. And the MOVIDRIVE knows that that is the application module that we have loaded to it, so it goes ahead and jumps us right into the monitor screen. And then just remember, if you want to see the key, you sometimes have to open up the window a little bit bigger to get some more information. Another thing I want to point out is that since we taught a new position for row 4, that is what was loaded to our parameter backup of our project. So if that was a scenario where you don't want to back up the new taught positions, then you would need to go back into the commissioning and then change whichever row you taught a new position to and correct it to a new value. Otherwise, that value will stay with the parameter backup since that was a physical change to a position variable in the program. Okay, that is the end of Lab 9, Part 2. In the next lab, we will demonstrate using the keypad to read fault codes and clear them. We will operate the MOVIDRIVE manually and edit different parameters, all while using the keypad. Thank you for your attention. Take care and have a good day.